to be writing or what we need to look at. We'll be looking at density of materials. We're going to look at pressure of a liquid. We're going to look at atmospheric pressure, number 3. Anything fluid means liquid. We are going to look at atmospheric pressure of liquids and gases. Number 4, we are going to look at formula connecting density, formula connecting density and pressure. Number 5, we are going to look at equilibrium of bodies in a liquid. Number 5, we are going to look at upthrust / upward force in a liquid. Number 7, we are going to look at Archimedes principle. Archimedes principle. Number 8, we look at law of flotation. Number 9, we look at Pascal's principle of pressure. And number 10, we look at application of pressure system. I think with these 10 principles I've tried. Under one topic, fluid mechanics. We're going to look at all these. Our textbook divided it into 3 topics. The density of a material is defined. The density of a material is defined as the mass per unit volume of the material. Density of a material can be defined as the mass per unit volume of the material. Mass per unit volume of the material. The density of a material is defined as the mass per unit volume of the material. Mass per unit volume of the material. All right, so let's look up and write the mathematical expression. Please, I've always told us a secret in physics. For every definition of terms in physics, there is a mathematical expression. Mathematical expression means there's a formula. The definition is density of a material is defined as the mass per unit volume. There are 2 quantities we have mentioned in that definition, which is what now? Mass and volume. Thank you. Let me ask this question as a reminder. Mass, is it a vector or a scalar quantity? Scalar. Thank you. Mass, is it a fundamental or derived quantity? Fundamental. Correct. Volume, is it a scalar or vector quantity? Scalar. Correct. Volume, is it a fundamental or derived quantity? Derived. Correct. Density, is it going to be scalar or vector? Scalar. Scalar, correct. Density, is it going to be fundamental or derived? Derived. Correct. Please don't forget that. We can see that in one number 1 or one number 2. Which of this is a scalar, vector, fundamental, or derived, whatever. All right, thank you for that reminder. And some are mute. Thank you too. So density, mathematically, we said it is defined as the mass. Per means divide. That word you wrote, P-E-R, per, means divide. So that means density equals to mass divided by volume of the material. Equation 1. Let me put it in a box. Density equals to mass over volume. Now, by symbol, the symbol of density, we use mu. Mu. Something like this, like a slant P. That's the symbol for density. The symbol for mass is M. The symbol for volume is V. Still joined to equation 1. That's the symbol. Join it like that. In words, this sign represents density. M represents mass. V represents volume. Hope we are still alive. Yeah. Okay, now let's write the unit for density. Very important. Now, mass is measured in kilogram. Density is measured in meter cube. Volume is measured in meter cube. So that means the unit of density will be kilogram per meter cube. They still put that. In some instance, it can be in a smaller unit. Mass can still be in gram or small letter g. Volume can be in centimeter cube. So that means we can still say density can be gram per cm cube. This is bigger than this. Kilogram is larger than gram. Meter cube is bigger than cm cube in units. Those metric units can be convertible. All right. So we can still jot it that it is a scalar quantity. So we don't forget. Density is a scalar quantity. As a reminder, it's a scalar quantity. All right, I believe, or let me just state it. Scalar quantities are quantities that have only magnitude. Magnitude means size, right? But no specific direction. So it's very clear. Density can only give us value. It can't measure a direction of that value. It can't measure a direction. Okay? Density just measures value. All right, let's break down volume. Since we know it's a derived quantity, the good news about derived quantities is that they depend directly on two or more fundamental quantity. Please listen to physics carefully, so you'll not be cramming formulas. Why am I breaking down volume? I'm telling you the reason. Density is a scalar quantity. That means it's also derived. It is dependent on two quantities, mass and volume. But mass is fundamental. I can't break it further. But volume is derived. That means it can be broken down further to get other fundamental quantities out of it. Now let's break volume. Volume is equal to area of the material. Let's call it surface area. Surface area of the material multiplied by thickness of the material. This will give us volume. The volume of any material is the surface area of that material multiplied by the thickness of the material. So by symbol, volume is V, area is A, times thickness, we use h. The thickness of a material is the same as the height of that material. So we can say V equals to AH. A for areal, H for height or thickness. Let's call this equation 2. Volume is area times height. Okay, now area can still be broken out because height represents length and length is a fundamental quantity, but area still has fundamental quantity embedded in it. So I can still break out area. In case you hear the word area, it can be represented in mathematics as pi r squared, where r can represent the radius of that material. Okay, so I can still have my volume V to be pi r squared h for area multiplied by height h. So this is the volume. I can call this 2b.